In this video clip, we learn how to classify signals. Signal can be classified in many ways, okay, as you may already know from signal and system class. An easy way of classifying a signal, for example, since this is a discrete time signal, so we could have the classification as, for example, finite length versus infinite length. Okay, the signal that is finite length, for example, here you could have, let's say I have xn equal to perhaps 1, 3, 1, 0, 2. Okay, and you see here right away that the length you count as 1, 2, 3, 4, 5. Okay, so the length equal to 5. Okay, so the length is start counting from the first element that is non-zero to the last element that is non-zero. Okay, so we call the finite length signal. Okay, so this one is finite length. Okay, the other one that is infinite length, for example, I have un, okay, so that is infinite length. And if I multiply by 2 to the power of n, that is exponential, okay, infinite length, okay, because n can be anything, okay. Therefore, L approaching infinity, and this is an infinite length signal. Finite length or infinite length, the easiest way to do is just to find the boundary, okay, in time, where it's the most left and it's the most right, and when you count the difference, right away you get the length of the signal. Finite value versus infinite value. Okay, in this case, what we are trying to see, okay, is the difference in terms of value. Okay, for example, the finite value has finite amplitude. Okay. Finite amplitude for all n. Okay, so you look at all possible n, okay, and then you see if the amplitude is finite or not. For example, if you have a signal which is a sinusoid, okay, so let's say I have 5 cosine 2 pi divided by 10 divided by 5 n, okay, so the amplitude here is finite, okay, even though it's maybe infinite length, okay, so in this case it's a finite signal, okay, finite value signal. Okay, it's finite value. The infinite value, obviously, the amplitude gonna explode to infinity at some point or minus infinity at some point. Okay. Another way you could do is the signal that is periodic, okay, versus aperiodic signal. Okay, periodic is the signal that has period. Okay, so that means fundamental period. So if xn equal to xn plus minus n naught, okay, for some value of n naught, right away we have the periodic signal. Okay. But if there is no period, or the period n naught go to infinity, or the period is not possible, is not exist, right away we have a periodic signal. Number 4, okay, you could also classify the signal by looking at its energy, or maybe you could look at it in some other means. Okay. So the next one, sometimes we look at the signal by its causality. Okay. So we use the term causal, non-causal, and anti-causal. Okay, so this 3 word has significant different. Okay. A signal is causal, C-A-U-S-A-L, okay, is causal, not casual, okay, it's causal if xn equal to 0 when n less than 0, okay. So a signal like this one, okay, would be a causal signal, okay. So you have xn, okay, and then it's equal to something, 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 but it's equal to 0 everywhere on the left, okay. So this sometimes we call the right-sided signal, okay, right-sided signal. Secondly, you could have a non-causal signal or anti-causal signal. So let's start with anti-causal first. Anti-causal is a signal that xn equal to 0, okay, when n is greater than or equal to 0. So it's a little bit opposite, okay, right? Because you will have at n equal to 0, which is here. So you will have 0, 0, 0, 0 on the right side, and then non-zero on the left side. Okay. So we will have the left-sided signal. The last kind of signal, we call it non-causal. Sometimes the non-causal signal refer as a two-sided signal. Okay, so two-sided signal. So the signal that exists on both sides, okay, the positive side and the negative side. Okay, so you might have something like this. Doesn't have to be symmetric, okay? So here, like so. If we draw a diagram, Venn diagram, you'll see that this is the set of whole signal universe. Okay. Okay. The signal that is causal is in the yellow circle. Okay. Outside of the causal here is the non-causal. Okay. And then you have the signal that is anti-causal. Okay, so the anti-causal may be here. Okay, the anti-causal here. So the circle one. Okay, so this is anti-causal. What I can say here is that every causal, if the signal is not causal, is non-causal. If the signal is anti-causal, is non-causal as well. Okay, so that is the diagram of the causality. Goodbye.